So today or the second part I should say, we're going to take a look at the sum of a geometric series. And you will notice we have two different formulas. So one is if you just want to sum like 5 terms or like 8 terms. And another is if it goes to infinity and if the ratio is less than 1. So we're going to take a look at this. Let's say we have 5, 10, 20, 40, 80, and it keeps going on forever. We could easily find the sum of the first 3 terms. 5 plus 10 plus 20, 20, 30, so we'd have 35. We could find the sum of the first, that's an S, sorry, of the first 25 terms as well. It would take a while, so that's why we would use this formula then. But the sum to infinity on this one, these numbers keep getting bigger and bigger, so the sum won't ever stop if it's going to infinity. We'll keep on adding. But if we looked at this, maybe it was going in reverse. Let's say we had 80, 40, 20, 10, 5, 2.5, and it kept on going. We could do the same thing. We could find the sum of the first 2. 80 plus 40 is 120. The sum of the first 3. 80 plus 40, 120, 140. The sum of the first 4. 140 plus 10 is 150. The sum of the first 5, well, that would be that plus this one, 155. The sum of the first 6, we add 2.5, so 157.5. But these numbers keep getting smaller and smaller. So to this value, we keep adding smaller and smaller numbers. So it's going to converge here to something. So the formula here for finding the sum, this should not be a 1 right there. It should be a u sub 1. So that formula right there, let's have you guys rewrite that one. So instead of a 1, please put a u sub 1. Is we take our first term, 80, over 1 minus our ratio, so which is 1/2. So we have 80 over 1/2, which is 160. Which kind of makes sense here. If we keep adding a smaller and smaller number, we're going to get really, really close to that 160. So, oops, where'd that go? Let's take a look at this first one. Find the sum of the first 12 terms. Well, our numbers are getting bigger and our ratio is 3, so we'll use this first formula. The sum of the first 12 equals our first term, so 2, and then there was a parenthesis, r to the n minus 1. So our ratio, 3 to the 12th minus 1, divided by r minus 1, so 3 minus 1. And I believe somewhere I put this in the calculator. Let's see. Yep, here it is. 531440. Alright, so there's that sum there, and if we take a look at another one here, find the sum of the series here. Well, if we look at this, it's getting smaller, and we're multiplying by negative 1/2. So this is one, it's infinite. So if we were to find the sum of this to infinity, we have to use that formula, u sub 1 over 1 minus r. So we have 16 over 1 minus negative 1/2. So we have 16 over 3 over 2. And let's see, we could do this without a calculator. 16 times 2/3. So we have 32 over 3. Well, that would be 10 2/3. Now, if we take a look at this, if I asked you to find the sum of the first 2 on this one, you could definitely do that. 16 plus negative 8 is 8. The sum of the first 3, we do 16 minus 8 plus 4. So we'd have 12. The sum of the first 4, 16 minus 8 plus 4 minus 2 is 10. And we could keep going here, or we could use that formula. Like if we needed to find the first, let's say the first 8. Our first term times our ratio to the 8th power minus 1, all divided by, and I can never remember which one it is, r minus 1. So our ratio minus 1. And if we put that into the calculator, we can see it's 85/8, which is 10.625. The sum of the first 8 there. But this one was dot, 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 so it was asking for it to infinity.